Hi everyone, we're going to continue working with exponential functions today. First, let's talk a little bit about the difference between a growth versus a decay function. Now, so far, you have um, worked with growth functions. You have already worked with a growth function. These are the kind of functions where in the basic format where y equals some sort of base raised to a power, the base is greater than 1, and the graphs look like this, like exponential growth graphs. They can be a little steeper than that, they can be flatter than that, but that's the general shape. Decay functions are a little bit different. A decay function is the exact inverse. They look exactly opposite of this. So although the basic equation is the same, where y equals some sort of base raised to a power, the base is less than 1 and greater than 0. So it's going to be a fraction. And those graphs are going to look different. They are going to actually fall towards 0 as we increase the exponent. So on a growth function, you increase as you go towards, as you increase, it moves away from 0 as you increase the exponent. And a decay function, you move towards 0 as you increase the exponent. All right, so let's take a look at why this would happen. And the only way we can do that is to look at the math. So we're going to look at the effects of applying those exponents onto this kind of a function here. All right, so you can see that our base in this function, in this example, is 1/5. We're going to continue working with that. And we're going to set up our table of values where x is the exponent and y is the result after we apply the exponent. We're going to use the exponents -2, -1, 0, 1, and 2. Let's start with the exponent 2. So when we apply the exponent of 2, y will equal 1/5 to the power of 2, which means that it will be 1/5 times 1/5, which gives us 1/25 when we multiply. All right. When we apply the power of 1, y will equal 1/5 to the first power, which is just 1/5. When we apply the power of 0, we should have learned in our previous work that the power of 0 will always give us the answer of 1, or the value of 1. All right. So now we have to apply the power of -1. And this is where we have to work a little bit with remembering what a negative exponent will do. A negative exponent will always take the base, this base, and turn it into its reciprocal. It will turn it into its reciprocal. So what this really means is that what we will get is the reciprocal of 1/5 is 5 raised to the power of, now it's positive because we flipped it. And so the answer here is 5. All right, let's do the same thing with the power of -2, where y equals 1/5 raised to the power of -2. Again, the negative will take the reciprocal. We need to take the reciprocal of this base. So that base will turn into a 5, now raised to the power of +2, which gives us 25. Okay, so what effect does that have on our graph? Well, when we sketch it, just as a matter of a quick sketch, you can see that when we have a -2 power, a -2 power would be back here on the x-axis. It's going to have a really high value on the y of 25. And then when we have a -1 power, that's going to bring the value all the way down to 5. And then when we have a power of 0, that's here on the y-axis, we get a 1. And then when we have a power of 1, we're going to have 1/5 which is really close to 0. And when we have a power of 2, we get even closer to 0. So you can see it drops as we increase. Drops towards 0, doesn't touch it. Drops towards 0 as we move to the right with our exponents.